Hi everybody. This video is about doing basic rotations in the coordinate plane. And when I say basic in this context, I mean 90 degrees, 180 degrees, or 270 degrees. Those are angles that make a right angle with the point that you start with. So here we have a problem, and I'm going to basically ignore the instructions. I really want the graph and I want the picture. But we are going to start with the point G, which is at 2, -5. So we're going to go to 2, 1, 2, 3, 4, 5, and this is where point G is. And we're going to rotate this. Now the problem says 90 degrees counterclockwise, but I'm going to show you how to do all of the basic rotations, and then we'll do a couple of more examples and we'll be done. So unless you're really good with imagining geometric shapes in your head, which not everybody is, I'm actually not very good at doing that, then this can be kind of troublesome. So the easiest way to do this is to remember a fact from Algebra 1. So from the origin, this problem says the origin, that's the point 0, 0 to point G. I'm going to imagine that I have point G connected sort of on an arm, and I'm really imagining the origin as a hinge. And we're going to be rotating counterclockwise. So I have to imagine this point rotating in this direction, which is why I said that not everybody's able to imagine this in their heads perfectly. Like I said, I'm definitely not. I'm not very good at picturing these sort of things in my head. So if you're not all that great at picturing this in your head, all you probably can see is, well, if I rotate 90 degrees, that means I have to make a right angle. So if I have this black line and I rotate this way and I make a right angle, well, I'm going to go somewhere in this general direction to make a right angle. So when I rotate point G, I know that G prime is going to be out here somewhere. Now that doesn't sound like a very good mathematical technique. You can't tell your teacher, well, I know the point's out here somewhere. They probably want something a little bit more specific than that. So here's where the Algebra 1 comes in. If you start with the origin and you go to point G, there's a topic you learn about in algebra called slope. And from the origin to point G, we'll think, rise over run, change in y over change in x, however you think about that. Well, we go over, that's 2 squares, and we go down -5 squares. So the slope to get from the origin to point G is rise over run, that's probably what your algebra teacher said, is -5 halves. Well, if we're going to make a 90-degree angle, another fact that you learn about in algebra is that, well, 90 degrees, that means we're going to be perpendicular to this line. And perpendicular lines have negative reciprocal slopes. Or instead of saying the word negative, some teachers say opposite reciprocal slopes. Either one is perfectly fine. So if we want to draw a slope that is perpendicular to this black line, the slope that we would have to draw would have to be, well, you flip the fraction upside down, that's reciprocal, so it would be 2 over 5. But negative or opposite means you change the sign. So instead of having a negative slope, we're going to keep this positive slope of 2 over 5. So let's start at the origin and count a slope of 2 over 5. Again, this is rise over run. I'll do the run first. So starting at the origin, we can count 1, 2, 3, 4, 5. That's a run of 5, and then a rise of 2. And there we go. We knew G prime would be roughly in this area, because we knew we were going to have to make a 90-degree angle. Well, you might say to yourself, especially if we're thinking really critically about this, well, there's another way that I could count a slope of 2 over 5. I could count to the left 5, 1, 2, 3, 4, 5, and then down 2. And you might ask yourself, well, how do I know that this isn't the answer? This line, I'll just do it dotted so it doesn't show up all that nicely. How do I know that this point, which I'm not going to label, should be G prime? And that's where you do have some geometric intuition as to what the problem asked. We want it to go 90 degrees counterclockwise. Well, counterclockwise is this way with the arrow that I drew earlier. So I know that G prime is in this general area because this is 90 degrees. Now, let's just pretend for a moment that the question said, well, clockwise. If this question said clockwise, well, I would go in this direction because that's the direction of the hands of a clock. I would take this same slope, positive 2 over 5, and I would count left 5, down 2. If this problem said clockwise, then G prime would be here. So you can't let this cause you confusion. It's not confusion. It's not that there's two different answers to this question. It's that you have to pay attention as to, are you going clockwise or are you going counterclockwise? So the first answer that I gave, the one that's circled over here to the right, this would be the counterclockwise answer, and this would be the clockwise answer. So let's look at another example. Here we have 90 degrees clockwise, and we're starting at the point E, which is at 3, 2. So let's start at the origin. That's here, and E is at 3, 2. 1, 2, 3, 1, 2. So point E is right here. I imagine that this is attached kind of on a hinge, and in this case we are rotating clockwise. So I have to keep that in mind. Clockwise, the same as a hands of a clock, goes this way, and we're rotating 90 degrees, so we're going to end up with a right angle. So I know that my answer is somewhere over here. I don't have to be too specific, but I sort of have to imagine this right angle, so I know I'm going to end up in the 4th quadrant. So now, let's think about the slope. Well, if we count our rise over run, we have 1, 2, 3, 1, 2. So the slope to get to point E, rise over run, is 2 over 3. And if we're going to be perpendicular, which we're making a 90 degree angle, just like your Algebra 1 teacher taught you, that's going to be opposite reciprocal. So the reciprocal of 2/3 is 3 over 2, but opposite reciprocal, so it's going to be negative 3 over 2. Now, you can't let this cause confusion. There are two ways that I could count a slope of negative 3 over 2. We could, if we wanted to, count, let's see, rise over run. Well, if I said negative 2, that would be to the left 2, that's a run of 2, and then a rise of 3. Okay, so it could be up here. Well, is that the correct answer? No, because we have thought a little bit about this prior, and we know that this is a clockwise rotation because the problem said so. So we're going to follow the blue arrow, and instead of counting to the left 2 and up 3, rather, we're going to count to the right 2 and down 3. Both of those are the correct slope, but only one is clockwise. So my point E prime is here. And you can count the slope to see it. It's a good idea to do so. So if we count this slope, we're to the right 2 and down 3. So we do have a slope, rise over run, negative 3 over 2, and you can see that this is a clockwise rotation. Now, something to keep in mind, and if you're watching this video, you're probably in my class. If I gave you a Khan Academy assignment on this, if you follow this rotation Okay, well that's also 90 degrees, but it's 90 degrees clockwise. Well, that's no big deal. But after you watch the next example, well, from E to E prime, well that's 90 degrees clockwise. Well, from E prime to this point, okay, well that adds another straight line. Okay, well that's plus 180. Another really common angle that gets used in rotations is 270 degrees. 180 plus 90 is 270 degrees. So this point, which we never gave a name, would be from point E 270 degrees clockwise. So this 90 degree rotation and this 270 degree rotation, they're always going to be related to each other, but always with this clockwise versus counterclockwise paradigm. Now, let's look at one more example. What about a 180 degree rotation? This one's nice, this will be fast. This is the easiest one to do. We'll start at the point F, which is at 2, 4, 1, 2, 1, 2, 3, 4. So here's point F, and once again, I'm going to connect this to the origin. That's our center of rotation, and we want to rotate this 180 degrees. Well, 180 degrees should make you think a little bit. Earlier in geometry, a 180 degree angle is called a straight angle. That is, it's an angle that forms a line. So if I want to rotate 180 degrees, the reason this is the easiest one to do is I just have to continue this straight line. So I'm just going to continue this line in the other direction. Now you can still count the slope if that helps. We're going over 2 and up 4. But if I want to continue this as a straight line, and I'll change colors, well, we're just going to go to the left 2 and down 4. So the point F prime, you can see, is going to be at -2, -4. So all you have to do is extend that line. So 180 degrees is the simplest one. And also notice that for a 180 degree rotation, it doesn't matter if you're rotating clockwise or counterclockwise because you're extending this line. It doesn't matter. Counterclockwise is the same as clockwise. Anyway, that's how you deal with the basic rotations. Hope that helped.